For the last section of 5.3, we're actually going to jump right into doing some examples because most of this is how to use your calculator to obtain approximate values. Remember, when you are using your calculator, the decimal that you get, even though it's out to 9 places, it's still considered an approximation. The only times that you have exact values is when you have fractions with radicals in them, unless, of course, you've got something where the fraction is 1/2, and therefore the function is 0.5. But generally speaking, your calculator is going to only give you approximations. So the first one, the tangent of 68 degrees, 43 minutes. You don't need to go about converting that 43 minutes to a decimal before you enter it into your calculator. Remember that in your calculator, if you go to Second, Apps, it actually shows you the angled menu. Option 1 is degrees, option 2 is minutes, and if you need seconds, then you hit alpha, and then the plus sign, and that will give you seconds. So when I enter tangent of 68 degrees, 43 minutes into my calculator, the answer that I get, which is an approximation, should be 2.56073524. Now, of course, I will accept this rounded to 3 decimal places, so that third place is a 7. Looking next to it, I have a 0, so I can write that this is approximately equal to 2.567. With the second one, the cosine of 193.622 degrees, I again will enter that exact thing into my calculator. I don't even have to go to my angle menu because it's already in decimals. And for this, I will get that it is approximately equal to negative 0.9718706,408. Again, it's acceptable to me to round to 3 decimal places. That's a 1. Looking next to it is an 8. So the answer that I would expect to see would be negative 0.972. These next two are a bit more of a challenge because we don't have a cosecant button or a secant button on our calculator. So we need to remember that the cosecant of any angle is really the reciprocal of sine of that angle, and that the secant of any angle is really the reciprocal of cosine. So to enter this into your calculator, what you are going to do is you are actually going to enter 1 divided by the sine of 35.8471. When you do that, you'll get that it is approximately equal to 1.707579671. Again, 3 decimal places is a 7. Looking next to it is a 5. So we'll say approximately equal to 1.708. For secant, what you will enter into your calculator is 1 divided by the cosine of negative 287. And you'll get that as approximately equal to 3.420303662. Looking at the third decimal place, next to it is a 3, so we will leave that answer as 3.420. These next examples, we're actually given the trig ratio or the trig function value, and we have to find the angle. Remember that when you're finding an angle, we untrig it or we use the inverse function. So in this case, we will use the inverse cosine of this ratio that we're given. Oops, that's a 6. And we can put exactly that into our calculator. To get this inverse cosine, you just hit second and then the cosine button. For this, we get that theta is equal to, we'll say approximately equal to, 22.9001237. 3 decimal places, look next door, that's a 1, so we'll give theta as 22.900 degrees. Those 2 zeros tell us that we actually rounded to that place. The cotangent is going to be a little bit different. We remember that the cotangent of theta is equal to 1 over the tangent. When we put this into our calculator, we have to enter the inverse tangent of the reciprocal. Like that. That's how we will actually get the proper information. And this is actually 1.4466. So this gives us that theta is approximately equal to 34.6543036. If I round to 3 decimal places, I get that theta is approximately equal to 34.654 degrees. Something to pay attention to. If you're finding the angle, right, cotangent of an angle, then you take the reciprocal of this number that you're given and you apply the inverse function to it. So here I took the inverse tangent of 1 over what I was given. I'm going to go backwards a slide. I can't go backwards that slide. But when I was given the angle, that's when I did 1 over the trig function of the angle. So pay attention because there's a huge difference there. This next example asks us to find all values of theta if theta is between 0 and 360 degrees, and we have that the sine of theta is negative square root of 3 halves. Now I'm going to do this without any charts. If I see that I'm looking at negative square root of 3 halves, the 3 and the 2 tell me that I'm looking at a 30, 60, 90 triangle. There's your 30. There's your 60 and your 90. There's 1, there's 2, there's square root of 3. So if I'm looking at something where sine of theta is square root of 3 over 2, sine is opposite over hypotenuse, then I know that theta has to be 60 degrees somehow. So now we're talking about a reference angle. The reason I know it's a reference angle is because this theta is, or this ratio here is negative. So what I will do is I will sketch myself a coordinate plane, and I will remember all students take calculus. Now the locations where sine is negative are going to be here in quadrant 3 and in quadrant 4. And these reference angles will be 60 degrees. Because I am looking at reference angles, I'm going to start in standard position here at the blue. The first goes this far. So it's 180 plus 60, which is equal to 240 degrees. And then I can start again at my initial side and travel all the way to the second angle, and that's 360 minus 60. So for this particular example, theta will be equal to either 240 degrees or 300 degrees. Notice that both of these will give me a sine value that is negative square root of 3 over 2. For the last example, you really need to read the information in your notes regarding this particular equation with regard to force and grade resistance. The only thing that really makes this trig is the fact that we've got this sine of theta in here, but if we have an angle, then it's not even really much of a trig problem. W is the weight of the vehicle. Theta is going to be your grade. Theta will be positive if you're going uphill, negative if you're going downhill. If you need to see an illustration, you can look on page 523. And that'll show you kind of what that means. So on a problem like this, I need to calculate F to the nearest pound for a car that weighs 5,500 pounds and going uphill with theta equals 3.9. Simple enough. This is kind of what we call plug and chug. Plug in the numbers, chug out the answer. So W equals 5,500. Theta equals 3.9. I'm going to put exactly that into my calculator. And when I do, I will get that F is, we'll say, approximately equal to, it asks for nearest pound, 374 pounds. Now remember these pounds, it's actually a force of gravity, not necessarily the way that we think of pounds. It's a force. Alright, so the next one, calculate F to the nearest pound for a 2,800 pound car traveling downhill with a grade of negative 4.8. Same thing. F is equal to 2,800 times the sine of negative 4.8. And again, that exactly goes into my calculator. So with this, my force is negative 234 pounds. The last question is more of a trig problem because here we've got the weight of the car and we have F, the grade resistance. We need to find the angle of the grade, and it does say specifically what is the angle. So if we're looking for the angle, that means I have to find theta. So grade resistance is 288. My W is 2,400. Sine of theta. So now I'm going to need to figure out a way to isolate theta. First thing I do, divide both sides by 2,400. That gives me 0.12 is equal to the sine of theta. If I'm looking for the angle theta, I have to untrig this, which means I take the inverse sine of 0.12 to get theta. I get that theta is 6.892 degrees. And of course, we can't forget the fact that this is a word problem and we need to write sentences for each one of these.